Hi guys, welcome to Learning Electronics Repair. I have something here from the building and renovation company, who are actually in the same commercial centre as my workshop. This is out of some sort of light fitting. Knowing this company, this will probably be one of a load of them in some rather posh villa or swanky commercial premises, a hotel or something possibly in the reception. I do know this is 12 volts, 50 watts. The lamp, I think this is probably an incandescent or halogen type lamp, and we can see this obviously is an integrated part of the fitting. So what do the guys do? I mean, if you can't get these anymore, and you may not be able to, what do you replace it with? I mean, you can't just like string something else up in the lovely looking hotel reception, can you? You've got to fix it, yeah, or have a bulb out. That's how I see it. These probably built into the ceiling or walls or something. So he said, Rich, can you fix this? And my usual response is, I don't know, but I'll have a look. Okay, so this is what we have. We can see something's happened here. Something has gone bang quite spectacularly in this area. So this will be, I am guessing, mains input. Yeah, that looks like a varistor or MOV voltage spike protection device on the mains. That looks like a, well actually no, that looks like a bridge rectifier. 102. Do you know what I don't see on here straight away? I don't see a large smoothing capacitor, so this is not like your standard switch mode type power supply. It does appear to have isolation via this galvanic isolation. This is the output. I'm guessing this clips into something, which is the light itself. This is the output. So yeah, we can see the high voltage and low voltage side. But what I don't see is anything in the way of a large smoothing capacitor, unless that thing is it, marked 102. Doesn't even sound. It's like makes a little bit of a rattling noise. Doesn't feel like a capacitor. Okay, so let's have a look to see where that thing is connected. Let's get some idea of what we have here. But the first question is, this area, is stuff here like burnt beyond the point of all recognition? And that's as close as I can get to it on the overhead camera, so we better try the microscope. Well, we have quite resistors that have gone bang actually. That one's a bit hard to read, but I think it's something like it's a low value. So we have 3R90, 3.9 ohms. We have 1100. Another 3R90, and we have something that I can't really read. I noticed that these are all held down with that horrible red glue stuff. Okay, what else do we have? We have something over here that's gone. 2202, I can read that one. Again, there's another one I can't read down there, coming from the negative end of the bridge rectifier, but it goes to that, and then it looks like it goes through that, and I suspect whatever this is, it's a low value. That's a 1R, 1 ohm by the looks of it. Okay, so we might be able to get somewhere here just by figuring out where things go. How does this thing work? So I don't see any ICs. I only see transistors or A4, M8, whatever, P. I only see 2 of those. Bridge rectifier, as I mentioned. That funny looking thing there, that one is connected here by the loops of it. So is that a fuse? Not sure where that one goes underneath, but that could be a fuse. It's going to one of the AC inputs on here, coming from power in. Yeah, so that's a fuse. Pretty certain of that. Yeah, I don't see any ICs at all, not on this side. Just the two transistors, in fact. And then we have the two large MOSFETs, MJE130, okay? Again, on this side, I don't see any ICs. So I think what we have here is some sort of self-oscillating inverter type thing, converting AC to 20 volts down to AC at 12 volts. Yeah, that seems to be what we have. So let's not mess about. I'm finding I'm using this more and more often at the moment. I'm getting quite a few things I'm struggling to desolder otherwise. Okay. You see how that changes a very difficult job into a just difficult job. Yeah, it's just plain difficult now rather than being very difficult. Okay, we can also see some tracks around here. Now that's helpful. So we'll check these out of circuit, but I'm pretty sure they will be faulty. Let's look. Well, that reads like a junction from the gate, which it shouldn't. Yeah, that's short. That reads like a junction, but that could be the parasitic diode. But we read it both ways. We know this is faulty anyway because of that. Okay. Again. Short. I'm assuming these things are MOSFETs, but I'm only just assuming. We better just have a look. Well, I don't quite see a B, but I see an A and a D. TO220, yeah, appears to be right. Let's have a look. Get rid of that thing. Right, so it still says it's an NPN transistor. I think these are used quite commonly in ATX power supplies. In fact, I might even have some of these. MJE13007. So, yeah. 400 volts, 700 volt peak, collector emitter. Yeah, you can see all the ratings there. 4 amp base current, 8 or 16 amp collector current. Okay, I do think I have some of those. Anyway, they're definitely faulty. What else do we have? Well, let's stick with the semiconductors because those are the most likely things to die. When the resistors die, we can clearly see that they've died. Okay, I'm wondering if something's dripped in here. See, like this deposit looks a bit different. Something has got in here, some sort of liquid, and caused the whole thing to blow up. Bridge rectifier. Well, it reads open across the AC as you'd expect it to do. Oh, but that reads like a diode. I think this has got a short on the output still. No, there isn't a short on the output. With a positive to the positive meter lead, positive bridge rectifier. That reads open. So why am I seeing a diode junction across the AC terminals? In that direction. And it looks like a diode junction. It's not a short. Something else wired in a strange way across here. Well, these are some high value resistors. This is, I would think, something to do with starting up the old power in this circuit. How's the bridge rectifier look? So red to the AC, black to the positive, should be a diode junction. Yes. We have a short there. That's why we've seen a strange reading across here. Okay, so that leg of the bridge rectifier appears to be short, which means that not to there, and that leg appears to be short. That's what usually happens with a bridge rectifier. Two of the diodes go short. We need to take this off the board before we go any further. Let's see how easy or difficult this proves to be, because again it's glued to the PCB. I think we're going to have to unsolder all four legs and make sure they are unsoldered, probably by either cutting them or bending them upwards, and then heat the whole thing up and get the glue. I mean, it might just come off with hot air, but I wouldn't be surprised if it actually damages the PCB before that thing will give it up. Okay, let's see. If we cut this pin, because we can always resolder that, yeah, if we wanted to. We can now just check to make sure the short is in the bridge rectifier, although I'm quite convinced it will be. Let's have a look. Yeah, so we know the short's in the bridge rectifier, so we are never going to fit this back on again, so we'll do this with all of the pins. Okay. And it came off quite easily. Like, actually the glue wasn't bad at all. So this red stuff seemed worse than that. Okay, so that's our bridge rectifier, DF06S. I'll just draw that. So here, so we have plus minus AC AC DF06S. I'm sure we can find a bridge rectifier of that sort of size. We'll probably get a datasheet, why not? Yeah, DF06S, 600 volt, 1 amp bridge rectifier. Okay. Don't see any problem with replacing that. I may not have one, but I don't see there should be any problem either getting those or finding something that will fit in the same place, equivalent. I'll just clean this up a little bit, and I think I see a blown track just there actually. There by the looks of it, okay. Yeah, I think that might have blown just there by the brush. Let's just clean this area as well, see if we can see any more visible damage as to what's happened here. So we can see that two resistors are basically obliterated the markings. And is this another blown track or something here? Or is that just a mucky mark? Bit hard to say. We can hopefully work that one out from where it is in the circuit. Okay. So this is where we might have a bad track. There's a bit of something there, by the way. Possibly came off my brush, that. Okay, so from here. No, we have a connection there. It's just a little bit bent, I think, but connection's good. Okay, so let's have a look at the rest of the semiconductors, which basically seems to be a couple of transistors and some diodes, if they are diodes. Let's have a look how it reads. So that should read open, and this should read a diode junction if that's a diode. Yes, and it reads like a diode. This one reads like a diode. Back to that one. Yeah, read almost the same as each other. Another one here. Reads like a diode. Okay. Just slipped. Yeah, it reads like a diode. So there's those three large diodes. I think I saw some small ones somewhere. Yeah, this thing at the end might be a diode. That reads open. Well, that reads open in both directions. And it sort of looks like a diode. Yeah, that looks very much like a diode, which reads open. That one, I think we'd have to try and figure out where it is in the circuit. Then we have these transistors. I suspect they're bipolar transistors because the output were bipolar. I don't think they'll be MOSFETs. Let's see. So this one. Well, that reads 0.307. That's a bit of a strange reading. That reads open. That reads the same in both directions. Okay, that's a bit of a strange reading on that one. How about the other one? So that reads open. Well, no, that reads like a higher reading, 1.5. That reads open. You would assume that if they are transistors, this end would be the base. That reads like a, well, it reads like an NPN in that direction, but not to there. So the next question then is, what are these two devices? Are they faulty? They don't look like bipolar transistors. Could be something else. So we'll have to look up these SMD codes and see whether that gives us some more information. So this one, RA4. These could be diode networks, but there must be some transistors on here somewhere. So I suspect they're probably transistors. Okay. RA4 then, and M8 I'll start with. Okay. The best way to go for these is something like SMD code RA4. Okay. So that brings RA4 marking. Let's have a look. That suggests it's a diode, I think. It says it's the right package, SOT23. That shows some photos here. R4, RA4, BAV70. So that says it's a diode. And you can see they have different equivalent circuits. Now, RA4 apparently could be any of them. Oh no, RA4 says BAV70, which is that one. So we will see two diodes to the center pin, which is normally the collector or drains, and with the anodes towards there. Let's see if it looks like that in circuit. So that is suggesting from here to here a diode, 0.572, and from here to here. Well, that certainly looks like the datasheet. A double diode. I mean, it could be that one transistor is oscillating with the output transistors as well. Let's see. The other one, M8. M8P, or just M8. Does that look like a diode as well? If it does, it's more like a fast switching one. Okay, let's try and find this one, M8 or M8P. SMD code M8. try that first. So M8P, somebody's tried to find also. Suggested it's a MOSFET, but that's a completely different package. Ours is SOT23. Okay, so let's add that, SOT23. See if that helps a bit. This site's quite useful, so S manuals, okay? So you can see straight away we have quite a lot of options here. M8P says N-channel MOSFET BSN 20 in the SOT23, so it suggests it might be this. Okay. If it's that one, then you would expect the gate to drain to read open and the gate to source to read open, but you'd find a parasitic diode between the source and drain, just like it shows you there in the symbol. Okay, let's have a look. I'm sure ours reads differently to that. So gate to here would read open, and it does. This would read open and it doesn't. This would read a diode junction and it doesn't. And that doesn't either. Let's unsolder this one and let's stick it onto the component analyzer to see what it thinks of that. It looks like it might be glued down. Again, I can see a little bit of like red under them. Sure, it is glued down. Let's see what we can do with it. So we'll add some fresh solder. Okay. I'm not sure it's going to come off this way at all. I don't think this will help, but we can always put some more solder back on. So we're next to that 7504, no 1504. That's like a 1.5 meg resistor between what would be the gate and source if we have the component right. Okay. Now I'm fairly sure we're going to have to add some fresh solder to this and see if we can get it off the board. The big problem with this is the glue. Okay, let's have a go. So fresh solder, tweezers. Can I get this thing to come off? I'm not sure, it might have moved a little bit. This is very tricky without breaking it anyway. Try get enough heat in from this side. Okay, back to the other side. Let's try to do it with 2 soldering irons. Of course, 2 soldering irons also suggest we need 3 hands. Yeah. Let's see, so we'll come in on here. We'll come across here. Is it going to come off? Yes. To test this, we'll have to just tag some thin bits of wire on so I can actually clip my component analyzer to it. Let's see if we can do it. Yeah, that's got it. At least it won't go missing. Now it's stuck on the end of my bit of wire. Okay. I mean, you could try soldering the thing to a little bit of Vero blood or something, maybe. That's another option we might do if this doesn't work. But again, I have it. Okay, one more wire and we can test it. It doesn't have to look pretty, guys, it just has to work, okay? There, okay, so we have it. We have it tagged onto our bits of wire. Let's try it. Okay. What are you? Yeah, you are unknown. You are not known, yeah? Let's just make sure those wires are stuck on correctly. Yeah, I would say they are soldered on correctly. They are attached, so... yeah, the analyzer should be able to analyze that. No problem. Let's look from the other side. Yeah, that looks good. So I think we have a couple of options here now. One is take off the big components from the other side so we can see where the tracks go and just reverse engineer it. It's not a very big circuit. Figure out what's connected to where, and from that, presumably, we can figure out what the devices are we don't know. The other one, I think, is the easier option, if it's a possibility, is chat to this guy and say, can you bring me a good one of these in, please, for a day, so I can just compare it with this one. I think that's what I'm going to do. It's call me lazy, taking the easy way out, Rich, but I don't think it is taking the easy way out. I think it's taking the most sensible option available. Yeah. Comment. So I'll get on and see if the guy can bring me a good one in. You guys can watch this video so far and comment on what you think about the way I'm going at it. Any other ways that you would go at it. As long as they work, it suits me, yeah. And we'll continue with it. Let's see if I can get another one to compare it with. Okay, hope you enjoyed it so far, and I look forward to seeing you all soon again on Radio Electronics. Ciao for now, guys.